this particular thing, this question from John. It's honestly, once you start like working with ink and you work with ink more often, the deployment itself is not really difficult. For me, usually what I do is whenever I do a cargo build, I don't even deploy from the CLI. I just go directly to contracts UI and then upload the .contract file. That process is like easy. Just top build, go to contracts UI, and then you upload it. So the only thing is just as Femi just mentioned, once you create your wallet, you could just go to poker.ui and just map everything in advance. That particular process is a little bit inconvenient, but you should understand that the reason why that process is coming up is because of some crucial optimization, some very needed optimization. The Polkadot ecosystem is trying to make sure that the ecosystem can easily interact with, the biggest block, one of the some of the other big blockchains out there, like especially EVM blockchains. The EVM ecosystem is very large. There's billions in that ecosystem. There's a lot of projects have already deployed their contracts, and regardless of whatever issues is happening on EVM, deployed contracts have been deployed. Funds that are stored in those contracts, they've been stored. There's very little that you can do to just tell them to migrate, So which is why from V6 upwards, the Polkadot ecosystem is trying to support Solidity smart contracts directly. And some of the implications of this is if you're going to try to interact with a Solidity smart contract or an EVM contract, more preferably, you want to also have like an EVM compatible wallet address. And that's simply what the map account, that's what the account mapping enables. So if you're going to be deploying an Inc V6 contract, before you start doing anything, you can go to the Polkadot.js app and then try and map your wallets, all the wallets that you're going to be using, just like how Femi showed us last week. I think the process itself for deployment is very seamless. All you need to do is run your code, build it, and then just drop the build file directly on contracts UI, and you already have everything working much easily. Frankly, it sounds like very simple and all of that, but if you're not very familiar with it, it might be a little bit confusing. But it's not something to try and it's not something that you should allow to overwhelm you. It's not something difficult at all. Yeah, Fred, is that a question?
Yeah. Thank you for the information. So I wanted to ask if how you're saying you want to start using Solidity, is that already implemented or it's in the works?
What did you say? Sorry, I didn't hear that.
Like you mentioned, they want to start using Solidity for smart contracts. So I'm wondering if that is already working, or it's
actually that's not what I meant. I meant that the ecosystem wants to support Solidity smart contract, not that they want to start using Solidity language. They want the Ink contract to be able to interact with Solidity, and you should be able to interact with your Ink smart contract the same way you would interact with a Solidity smart contract. So using Ethers.js or Vim, or in a React app, you might be able to use like Wagly from your front end to interact with your Ink smart contract. That's what I meant, not that the Polkadot ecosystem wants to start writing Solidity. Although you can write Solidity, I think for V5, I'm not entirely sure about Risk V. I think it's possible actually. You can compile your Solidity code directly into like WebAssembly module. I mean, you could do that for V5, and then your contracts would be directly that way. And I think you can also compile the Solidity contract into Risk V as well, because Risk V is language agnostic. It doesn't depend on only one single language. Does that make sense?
All right. Yeah.
Okay. So we're gonna. Is that another question? Okay. So we're gonna start with this week's agenda. So let me just share my screen so that we can jump in. We have like quite a few things to talk about this week. So this week, actually, we're going to actually get our hands really, really dirty, right? Before we got our hands dirty, but you could just call it like little stains on our hands. But this time around, we're going to try and get our hands dirty, which means we're going to write smart contracts that are at least testnet ready. At least you can push this on testnet. We're going to try and do some things. So before that, the plan is, the plan for this week is actually to deploy some quality contracts. I mean, no like templates. Last week we talked about templates, which was very vital in getting us familiar with all the different moving parts of an ink contract. But this week we're going to build our own contract that's not just a template. But before then, I think it's very crucial that we talk about like the ink contract storage and the allowed types that ink exposes. I think it's very vital that we talk about those. So just like we already seen from last week, ink is pretty much the same thing as Rust, right? It's just as if you are building a framework, a Rust framework, and exposing this for like smart contract development. According to the ink contract page, actually, ink is a domain-specific language, so it's like a Rust DSL that can be used to build smart contract. At the end of the day, after all these language and English, ink is pretty much just Rust. So when you're writing ink, you're writing Rust, but the only thing that ink allows is it doesn't just expose all the features that Rust has, because wherever you're putting your ink smart contract is going to be in a sandbox environment, right? That's the first thing. We also want to try and make sure that whatever types we're using, they're not too heavy. They're not, prone to errors. They're not too complicated. So which is what the ink ecosystem has done with Rust. So it's as if they swallowed Rust and then they vomited something wrapped around Rust. So, and they call it ink. So I think I actually want to be able to write something down, but let's continue for like this for now. So you see, I'm putting two different versions of ink. So we're talking about ink v5 and ink v6. This particular bootcamp is actually going to be teaching a lot more about v6, but I believe if you're going to learn about v6, it makes sense to you should know where v6 is actually coming from. There's v1, v2, v3, v4, v5, which is pretty much the same thing, 1 to 5. I'm saying they're the same thing because they all compile to WebAssembly, right? And v6 is like a different machine. It's just like, no, leave WebAssembly aside. I'm no longer using WebAssembly. I want to start using RISC-V. So that's the major difference between both of them. So what is ink v5? Ink v5 is pretty much the version of ink that compiles to WebAssembly. And this WebAssembly, on the substrate chain where you're going to deploy it, there's a WebAssembly interpreter that's going to read this WebAssembly and tell the substrate chain that, oh, this code that has been deployed on you, this is what it's trying to do. So that is what v5 is. v5 is pretty much like using WebAssembly module under the hood, and v6 is using Poker VM. I mean, it's using RISC-V, but this RISC-V is going to be interpreted by the Poker VM, which is Poker.virtual machine. There's EVM, now there's Poker.virtual machine, which I believe it's a very, very fantastic development on what we used to have with WebAssembly. So the differences and similarities between both versions, technically, the major difference is what I've just talked about, WebAssembly module, and then v6 uses RISC-V. Those are like the major differences. There's also like differences in types, which we're going to be seeing along the way, right? Because the v6, it allows you to interact with Solidity smart contracts from within the ink contract. It allows you to compile your ink contracts into like a Solidity compatible ABI, and then you can interact with this smart contract using like the EVM tool chains like ETAs and so on. You can also interact with it using like the Poker.js, which is like the front-end extension, let me call it the TypeScript extension that you can use to interact with your ink smart contract. I believe in coming week, we're going to be discussing front-end integrations with your smart contract, and you're going to see how you can, interact with the ink contract. But for now, I think it suffices to know that there's a difference in how the contracts are deployed, right? And there's also differences in how the wallet addresses are interpreted on both versions. So for v5, you're expected to only be dealing with like substrate compatible wallet. So you see starting with like, I think 5S or something on your Poker.js extension. You see it that way. And those are like substrate wallet. Ideally, they both use so the substrate account and the v6 account, which is EVM compatible, they both use the same technology, which is like the elliptical curve cryptography, right? But we're not going to go deep into like elliptic curve. But one thing that we just want to make sure we understand is the fact that Substrate wallet is using like a version of elliptic curve, which we call SR25519, while Ethereum wallet, they use the same elliptic curve that Bitcoin uses, just with like a slight variation in the formula. So we wanted to make sure that the V6 is compatible with EVM wallet. So when you deploy your V6 contracts, you see a very key thing at the top of the page. You see it written. Let me copy this actually. Let me bring this over here. Let me bring this over here so you can override this. You can see what I'm talking about. This is like an Ethereum compatible wallet. You can see it starts with OX67, blah, blah, blah. But when you look at the substrate wallet, it starts with 5C, 83, and so on. And the cool part about this is you deploy this using the in contracts UI, but it's giving you an EVM compatible wallet address, which is like a key difference in between, both versions, which is V5 and V6. I don't know if that makes sense. Let me go to the last point. So why learn both of them? I think I've touched on this. The reason why we want to, go from V5 and jump into V6 is to give us like a background, because V5 is actually, let me say, is fully Polkadot. V6 is also fully Polkadot, but it allows you to, deal with EVM wallet. So understanding where V5 is coming from will give us like a good background to building with V6. And you find out like once you can build with V5, building with V6 is pretty much the same exact process. It's pretty much the same thing. There's no difference between both of them. So let's go to the next page. The next page. I don't know if anybody has any question about that before we jump into the next. Yeah, Valerie.
Hi, how are you?
Yeah, great. Go on with your question, please.
Okay, so I learned that in V5, it comes with it comes with the contract pellets, which are the sub-modules that allow developers to execute and run smart contracts on the Polkadot network. So I was asking, like, in V6, which part does that?
That's a very good question, actually, and a very nice observation, which is one of the major differences that I actually didn't mention. So V5, you're right, it uses pallet contracts, which is the pallet contract has like, let me put it this way in a very simple term. The pallet contract is kind of like the WASM interpreter. So when you deploy your Ink Smart contracts, you're actually telling it to interact with the pallet contracts, and that's for V5. But for V6, it uses another pallet, which is called the pallet revive. The pallet revive, is the one that's able to interpret the risk V. Ideally, I don't know if you want to actually, allow support for pallet contracts and also allow support for pallet revive. But if you're building your substrate chain, you could try it out. But the pallet revive, any contract that wants to support any substrate chain that intends to support V6 smart contracts, all it needs to do is to, integrate the pallet revive. And if you're planning to support V5, you need to integrate with pallet contracts. And one key thing that you've been using, I don't think you're very familiar with that, but you've actually been using the pallet revive when you go on Polkadot.js apps and then do that account mapping. That function to map the account is actually on pallet revive. You see, so once you map your functions, you're doing that on pallet revive directly. So that's the palette that allows you to deploy V6. Does that answer your question?
It does. Thank you.
Okay, awesome. So now we're going to go into this interesting part, which is like ink storage types. And I'm making it specifically like ink storage types because the ink storage itself, which is a macro that, is kind of like the store for your smart contracts. When you're building your smart contract, at the end of the day, what you want to do is to be able to store data, right? You want to run some computation on some data on chain and then store it somewhere. So the store where you're storing it is the ink storage. And this ink storage, it's kind of like, should I say it's stingy with the types that it allows? And this is on purpose because for optimization reasons, the ink storage, it doesn't just allow any single thing to just, it won't allow you to just store anything. So for example, if you're very familiar with Rust, the Rust ecosystem itself, which is like the Rust STD, there's certain types like the hash map, like box, like arc, mutex, and all of that. all these guys, you won't be able to use them on the ink storage. So you won't be able to store a type that's like a reference counter, because you don't want to deal with references when you're storing data. You want to like pass all the ownership to the storage. So which is why it's very important for us to know the storage types that are allowed. But before we do that, we're going to talk about a very, very interesting concept. I think I should actually start a project over here just so we can, get familiar with this. I'm gonna do, okay, where is this? Let me open a folder over here. Actually, let me do it from here. So I have a contracts folder over here. And what I want to do, I want to start a new project. So I'm gonna say, is it pop new? I think I have the contract over here. Yeah. Let me use the Flipper contract. So if I don't pass any templates, I think the default is Flipper. So let me just call this contract. What should I call this contract? Demo V6 Inc. Yep. Let me say Demo V6 Inc. And I'm gonna call this. Yep. So I have Demo V6 Inc. And now I'm in here. I'm gonna see what it has, just a cargo.toml file. You know what? Let me just open it from here. I'm gonna open it directly from here. Documents, what's going on? Projects. This is I think I have it over here. Demo V6 Inc. Nice. So now we've got this opened. The first thing, I know you're all familiar with this, and as you can see, we're using Inc V6. This is the key identifier that this is a V6 project. My username and my email, we can all leave that one. We don't care about that. So where I actually care about is this guy over here. So you can see when you're dealing with ink, the first thing that you notice, I'm sure we've spoken about this last week, is the fact that the ink ecosystem, it runs in a no STD environment, especially in production. So when you push your ink contract into like prod or like Canary network, like Kusama or anywhere, it is not going to allow STD. And this means that the Rust STD crate, which is like, let me get this over here. Let me get this over here. Let me get this over here. I'm gonna close this guy very soon. But this is Rust STD. This Rust STD is a magical crate that exposes pretty much a whole lot of things that Rust relies on. So you can see it exposes vec, option, results. If you go deep into this Rust STD crate, you find out like it also exposes the integers, it exposes strings, different things. You can see string over here. So what Ink is saying is you're going to be running your smart contracts, but you cannot rely on these STD crates, which means if you are building your smart contract and you are doing something like vec, you want to initialize a new vec U8, you won't be able to do this. You can't rely on this because when you go into production, the smart contract is going to be sandboxed previously to WebAssembly module and currently into like RISC-V ecosystem, which means you can't count on this Rust STD crate. Pretty much that's what it means. So that is the meaning of this guy at the top of this page. So no STD, no main. It means this has to be a library, not just like an execution something, which is the main.rs file. When you have main, that means you want to just execute it. So it has to be in a no STD environment for production, which is one of the very interesting things that we have to pay attention to. Is this shared? Let me put you back over here because you're very important for us. So yeah. So we've spoken about this. We've spoken about what the no STD flag means. And now we're going to talk about the Rust STD crate versus the Ink Prelude crate. So the Rust STD is what I've just showed us, which is this guy over here. Normally, whenever you run like a Rust project, this particular crate is going to be available to you magically. So you don't have to, put it in your dependency or anything. It's something that you have in your Rust project. But in Ink, you don't have it. So you have the Ink Prelude project. This is this particular guy. And, I think it's very key that you pay attention to this particular crate over here, because this crate is the guy that swallowed the Rust STD and then, vomited itself. It vomited this Ink Prelude. So if you take a look at this guy, you can see that it exposes quite a number of things like the vec. You can see that it exposes like string. It also says it exposes box. for heap allocation and so, but you wouldn't be using this in ink storage. So the reason why you have this here is, I mean, you might be writing your ink logic maybe within your function or internally. You don't want to store it. You can still like you can keep the function, the types boxed, but when you're storing them, you won't be able to store this box type. So we're going to come into how you can, store values like those, later when we along the way. But you can see there's quite a bit of functions. There's collections, there's linked list, hash map, and all these guys. You won't be able to store these guys technically, but you can store the vec, which is this guy over here. So the ink prelude, think about it as the equivalent of Rust STD in an ink smart contract. So it has swallowed these guys, and then it's spitting out its own versions. It also spits out its own versions of U8, the integers. The only thing that you don't have on this place is floating point values. And we also come to why ink does not support floating point values. Technically, most smart contracts, they don't support floating point values, and it's actually to avoid like a whole lot of inconsistencies and to avoid like issues along the way when you're developing your smart contract. I don't know if that makes sense. Awesome. So we're going to talk about the list of allowed types now. So you can see these are the basic things that you can, store within your ink storage. If I go into this ink contract, you can see that it allows me to store a Boolean. If I also want, I could also store something else like name. I could store it as a string. Obviously, this string is exported from ink prelude, right? So just know that that is where it's coming from. You can store it as a string, and this pretty much works similar to how the normal raw string works. And this is an owned value, so you won't be able to store something like this in an ink storage because this is a reference. And if you do this, you're just pretty much trying to confuse the ink, the contract runner, because it's going to be like, okay, you're giving me a reference, but how do I know this reference is going to be valid whenever you need it in your function? So which is why whatever you're going to store here, it needs to be an owned value so that the contract can, take over possession for that. So that is that. You can also store Boolean. We've seen that. You can store a vec. So a vec is like a list, a dynamic list. You can grow as large as you want. You can grow it to like very, very ridiculous lengths. But along the way, it's not very optimal to actually have this vec grow too much because, when you need to find something, that means you have to go through the vec. And as you do that, somebody is paying for that gas. You have to pay for the gas that you're using to go through the vec a number of times. So there's more optimal ways to store like lists. At the end of the day, it comes down to trade-offs. So we're going to look into like other alternatives for vec before we end this particular session today. You can also store a string. I've spoken about string. You can store a string. You can store tuples. So tuples are pretty much the same thing as vec, right? The major difference is a tuple can hold like different types. So you can store a string, number, struct inside a single tuple. So that is the major difference. And you could also store that directly inside. Somebody's asking the question, why are floats not allowed? Actually, let me just answer that now. Actually, I was looking to push that to a little bit later, but let's just answer that now. Very good observation. The ink storage allows you to store like unsigned integers and signed integers, but not floating points. And the reason is very simple, right? So when you're dealing with floating points, it's very tricky because you might have like 3.999, and then you could do a subtraction that would actually give you 3.999, but the two values might not be the same thing. And this is a very common thing with like floating points, even in like basic languages like JavaScript. I'm sorry, JavaScript guys. I don't mean to say JavaScript is basic or too small, but we're dealing with Rust over here. So sorry guys. So technically, when you have like a floating point, it's very difficult to have like precision because you could be trying to pass like a floating point that is 1.77 to like 320 decimal places. It's very possible. There's no reason why you can't, because technically, think about a number like pi. pi is equal to 3.1423, blah, 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 blah. It never ends. So it just keeps going. So at the end of the day, what you're going to end up doing is you're going to end up approximating it to like nearest 5 decimal places. The moment you do this, you have lost like a whole lot of information about this number right here. Because the next time someone comes and passes in pi, but is doing it to like 2 decimal places, like 3.14. It's pretty much the same pi, but when you compare these two values, you're always going to get false. They're not the same values, but it's the same pi. So you can see now we've introduced like confusion to the smart contract. And this is one major reason why smart contract do not allow floating point integers, because floating point numbers, not integers, they can't be integers anymore. That's a tautology. So that's why smart contracts do not allow floating points. I don't know if that makes sense. Yeah. One interesting thing about floating points is, you really can't escape it, because at the end of the day, when you're sending money to somebody, if you have just 2 dots and you want to send something, you want to send some dots to somebody else, you don't want to send all the 2 dots, but you don't want to just split it in 2. Like, it's my money. Why are you taking one? Why should we do 50-50? So you want to send like 25% of it to somebody. 25% of 2 is like, I think 0.25. So that's like a floating point already. So how do you pass that to a smart contract? How do you let a smart contract know that you only want this person to access like 25% of your money? So that is one reason why smart contract, they introduce the concept of decimals. We're still going to come to the concept of decimals when we talk about balances, but you just keep in mind that there's this concept of decimals, and that is how smart contracts, they tackle like the absence of floating points. So I think that answers why floating points are not allowed. We also have like enums. Enums are also supported, enums are supported as well in the storage, except when you want to pass an enum, you have to let the smart contract know how to, encode and decode it. So the reason for encoding and decoding is because if you're storing any value on chain, so let's say you're storing a string on chain, the smart contract is not going to just store the string just the way you pass it, right? So it's going to use something that we call scale codec, like parity codec, which is this guy over here. Let's see, parity scale codec. So this guy is like a coder. He's going to take whatever value you are trying to store and is going to encode it to scale format, which is the format that the pallet contract or the pallet revive understand. So you need to let your smart contract know exactly how to treat your enum or the second big boy, which is a struct. You need to let your smart contract know how to treat both of them. So we're going to come to like scale codec as well when we actually write some ink contracts. For now, we're doing like a lot of like a lot of theoretical talks. So we also have arrays and vectors, pretty much the same thing. It's just that, arrays are fixed lengths. So pretty much the same thing. No floating points allowed. Very, very important. And keep that in mind. Any other question about those ones before we go into like more advanced types? Awesome. If there's any question, you can always drop in the chat. So we also have some ink exported types. So these are like types that ink is just like, oh, I know you're going to need this guy, and I want it to be uniform across all boards. So wherever you are deploying your smart contract from, I want you guys to use this particular type for so usages. So some of them are like the mapping. The mapping is like a very high profile type in ink contract. Let's go to mappings over here. We're going to go into storage layout. It's just, I think, yeah, right before this guy. So the mapping is right over here. You can read about this mapping. At the end of this course, I think we're going to share the links about all these guys. But we can read about this mapping. One thing about mapping is, so a mapping is kind of like the equivalent of a hash map in a smart contract. So when you talk about let's say you're trying to store you're trying to store users' information. So you want to store user ID to wealth. So you want to say for each user ID, this is how much money they have. So you pass in the ID, you're going to say the ID could be anything like U32. And then the wealth can be like, let me use a very basic type. Okay, let me say user ID to adults. So if it's an adult, the ID will be true, else the ID will be false. So you want something like this. You want something like this on the mapping. This is simply how a mapping works. And you can look at it in this way. So a mapping could be seen to be something like this. Key, value. So the key will be this first type, and the value will be this guy. This value can be anything, it can be pretty much anything, as long as it's a type that can be stored by the ink storage. So that means it can be a vec, it can be a string, it can be anything. And one very interesting thing about this mapping, we're still going to talk about this concept, but I just want to introduce it to us early, is the fact that the mapping is lazily evaluated. And this is very useful for optimization processes, right? By lazily evaluated, I mean, the mapping is not just going to evaluate anything. So let's say you have key one, and then you also have key two, key three, key four, key five, key six, and so on and so forth. So you have all these keys within the mapping. If you are only trying to read key four like this, the mapping is not going to bother about all the other ones because it's a lazy guy, right? He just wants to do what you asked it to do. He's not proactive, so he doesn't want to do more than that. And this is useful because the mapping can take as many keys as possible. It's not limited. So you can take hundreds of keys. So if you are only interested in reading information about user ID 1, there's no point in the mapping trying to know what is user ID 2, 3, 4, 5. So it lazily evaluates the results for this key only. So whenever you do this, you are only getting this guy. This is different from eager evaluation like the VEC. So this is one thing. When I was talking about optimization for VECs, let's assume you have a VEC, which is like a list of items, and then each item is like the ID of a user, right? And then you have like the length to be like around 200. And all you care about is, the 10th index. You just want to pick out the 10th person. At the end of the day, when you read the value of this storage, it's going to first give you everything in the VEC. So that means it has evaluated all the values for you, regardless of if you only need one thing or two things, it's going to give you the value for all of them. And now you can now unpick which particular index you care about. I mean, I don't think it's that much of a bad idea, but depending on your use case, you might not want something like that because, if you have like too much values and then this guy is just being eager, is oversabi, is just bringing everything out of the crate for you. And at the end of the day, your smart contract is going to have evaluated those values under the hood. And, that adds to the cost of calling that particular function. So we're talking about some optimization right now, which is not really the topic for this week, but I'm just delving into that one for now. So that is how the mapping works. We also have this guy, which is the storage vec. So the storage vec is like a lazy vec. Think about it as a lazy vec. The storage vec is also a type that the ink contract exposes for us, right? So the same thing as the vec, it works pretty much the same way, right? When you call storage vec, you pass it the same way, storage vec of U8. And this guy is going to have a list of values. You can go up to like as much as possible, up to 1,000, up to. But the key difference between a storage vec and the normal vec, the ink prelude vec, is that the storage vec is lazily evaluated, while this guy is eagerly evaluated. So for the storage vec, when you try to read values from it, you won't be able to read everything. So you're only going to be able to read value at a certain index. Oh, I think I need to actually show us how this guy works under the hood, right? I think I need to show us how this storage vec works under the hood. Let me get a very, very basic example of the storage vec. Okay, let me use something like this. Let's call it people. So this our contract. Let me not call it people. Let's say this our contract. Since we're talking about the flipper contract, let's say it has something called flippers. So these are all the guys that can flip on this contract. So yeah, very good name actually. They can flip since it's a flipper contract. And when they flip, we're gonna pass in their wallet addresses. So account ID. Don't mind this guy, but this is an account ID. So let's see something. There's an error in the constructor because for every single value in the storage, you have to initialize it. So you have to give it an initial value. So that's what I'm going to do right now. I'm going to say flippers is equal to storage new. What's going on? Come back here. So now hopefully this error should disappear. Yeah, now this error is gone. And now I'm going to say something like, let me call an ink message to update the flipper. So we're gonna say only people that are flippers can flip the message. Awesome. Let's just add that. So let's say update flipper. Let's say no, add flipper because you only want to add one of them. And then you want to say mute self. And then the user ID, let's call it user ID. It takes an account ID. And then what does it do? It just says results. It doesn't return anything. So it doesn't return anything. And then that's it. Wait, this result guy. No, let's take this guy out for now. We've not spoken about this guy, so let's take it out. Let's just say this is a function that it doesn't know what to return. He's a little bit confused about what to return. So now what we're going to do is we're going to first check if we're going to add a flipper, right? We want to make sure that the flipper does not exist already. So now we're going to run into a quick problem. How do we do that? Because for this storage vec, you can't iterate through it, right? So you won't be able to iterate through the storage vec. So ideally, what we want to do is instead of using account ID, you have to be very smart with this guy. We're going to be using a U8. So this U8, actually no, let's not do it this way. Let's say let's stick to how we did it. We're going to say account ID, but now we're going to have flipper counts. So we're going to have total number of flippers. And very soon we're going to see why I'm adding, because of this flipper now, I have to add an extra thing to my storage. I'm going to call it, so it's going to start from 0. So the reason why I'm doing this is for every user, technically, they have an account ID, which is an ID, right? But let's think about this account ID as, okay, let me do it this way. Let's say it's storing a tuple, the account ID, the user's net worth, U64, the user's, what else? The user's age, let's say U8, because they cannot be older than 256. What else can we store on this guy? 3 things are enough, actually. So storage vec. So now, for each flipper that we add, we're going to increment this flipper count. So that means each flipper is going to have an ID of 1, 2, 3, 4, 5. So if you're going to fetch the information about flipper 1, you know that you want to add the flipper with the account ID and certain age, which is U8, and net worth. Please let me know if this is a little bit confusing because I feel like I've stepped it up a notch, right? So if you have any question, please don't hesitate to ask, and I'll pause and explain. We still have like 675 minutes at least. So what we're going to do here is, since we're keeping track of the flipper counts, so the moment we add a new flipper, we're going to give him the ID, ID of 1, ID of 2, and so on and so forth. So now, how do we know for this? Whenever we're adding a new flipper, we won't be able to know if the flipper with this user ID, age, and net worth already exists. And this is one of the trade-offs that you sacrifice if you instead were using something like vec flippers, which is vec storing the exact same thing, vec flippers. They're storing pretty much the same thing, but now if you want to add a new flipper here, you can just check, you can say self.vec flippers dot contains, you can just say dot map. You can iterate through it and map, you can do pretty much the same thing. This is pretty much the same function that an inc contract would have, like a normal ROS function would have. Let me just take this suggestion that this guy is giving me and remove every other thing. So what I want to do is I want to find the flipper that has the account ID equals to this one. So we can do that using the vec. But if you're dealing with the storage vec, because the storage vec is lazily evaluated, it's not going to give you the whole array, right? You can see that when you call sep.vec flippers, it gives you the whole array. But when you do the same thing with flippers, you won't be able to get the whole arrays. So the only thing you can do is you can do a .get function, and this .get function is expecting an index. So it wants you, it's assuming that you know the index, you know the index where you're trying to fetch the user from. So let's assume this is very useful if you're trying to update the flipper. So let's say this is not an add flipper, but instead it's an update flipper function. And then, you have to pass in the index of the user, because since you're trying to update it, you naturally know where the index is. So this is what you pretty much have to do. I don't know if that difference is clear. I saw your question over here. While I'm reading the question, you can let me know. Someone said, if you are adding a new struct, we should update its constructor and message as well, right? If you are adding a new struct, how do you mean a new struct? Oh, are you talking about the storage? Oh yeah, if you're adding a new storage, yes, you have to always update it. You have to always initialize it. So this is a storage, not to be mistaken. Yeah, actually, you're not adding a new struct, actually. I think it's because of this guy over here. So the storage itself, it's actually a struct, right? But it's a struct that has been, it has this in storage macro. Is the account ID not a struct? Actually, no, the account ID is not a struct. Let's see if you can read what it is. This guy is not giving me access to it. But the account ID is actually, if you look at the definition of account ID within the in contract, it's something like this. It's just a type that the in contract exposes, something like U820. So this is what the account ID looks like for V5. For V5 contract, this is what the account ID looks like. And the reason why it's like this, what's going on? What are you talking about? Whatever, dog. It's something like this. So it's a 20 byte array. So that is what the account ID is. And this simply represents a substrate address. So substrate addresses, they're very long. You can see it like, you can say 5S, blah, 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 but it's no longer than 20 bytes. So which is why the account ID, I mentioned that Inc itself exposes some types just to ensure consistency across the board. So the account ID is one of such types, and it can just be used to represent a user's address off chain. So if somebody is trying to pass an address on chain, that is what the account ID represents. I don't know if that makes sense. And the moment you add a new value to this struct, which is this storage struct, as you can see, pop struct is a struct, but it has been marked with this inc storage macro, and that's what makes it the storage. So if you're trying to store anything onto your smart contract, you just need to add it inside here, information. The moment you add something like this, it has to be initialized in your constructor. So someone is saying, is the account ID not a struct? Yeah, we've answered that already. And Alan is asking, I would love you to explain by what we mean by constructor. Okay, yeah, I can do that. So this constructor, if you're familiar with a language like TypeScript, so where like object-oriented languages, if you define a new object, you can if you define a new class, you can initialize that class with like default values, right? So that is what this constructor does for you. So the constructor is something that allows you to initialize your storage. So if you're building a new contract and you're storing some values, you have to always initialize every single instance of those values, no matter how many they are. And honestly, it's not really a good idea to store so many values on a contract, right? it's not a very good idea. So you might store maybe like 10 values at most, or 15. 15 is like, oh, let me push it as much as possible, you're pushing the limit. So, but no matter what values you do, you have to always initialize them in the constructor. And one cool thing about the constructor, I know we mentioned this last week as well, you can have as many constructors as possible. So like you can have another constructor that initializes the contract in a different way. So maybe if a rich guy, rich new rich, yeah, let's say a rich guy is trying to, interact with your smart contract, he's going to be putting like millions inside your contract. And you're like, wow, I don't want this guy to use the same one that I'm giving to like my not so rich folks. You can give them their own constructor and then allow them to initialize it in a different way. When you're interacting with like your ink contract on the contract UI, it's going to give you the option to initialize it using any of these constructors. So it's going to give you each of these constructors as an option to initialize your contract. What that means is somebody can initialize the contract with like 1,000 flippers already because their wallet address is different, because they're rich. Another person can, initialize it without anything. But you have to, initialize every single value that you're putting in your storage. Does that make sense? And the constructor, this is the macro. We're going to talk about macros next week in more details. Like a very well experienced macro person is going to talk about this. But just know that ink, when I said ink is like a Rust framework, right? It's because of all these macros. There's the ink contract macro, which is what specifies this particular module. But at the end of the day, this is just a normal Rust module. But because you've put in this ink contract at the top, the ink crate is going to take this and is going to add some extra functions. That is simply how macros work in Rust. So the same thing with the ink storage. There's a lot more constructors. There's tens of constructors that I'm not citing in this particular place over here. But the key thing is this constructor, you have to call it when you initialize your contract. So that's it. I don't know. Is the difference between the storage vec and the normal vec, is it clear now? Does it make sense? All right. This lazy guy, I'm not going to talk about this. I just added it here, but I don't want to add some more, I don't want to add more complications. If you're building your smart contract, you can build like tens of smart contracts without even using this lazy. So at the end of the day, it's an exported type by ink, but it's not something that we need to really worry about for our use cases. Along the line, if you have to use the lazy, you find it intuitive actually. So other useful types are the account ID. I mentioned that the account ID is pretty much a 20-byte array, right? So that is what I just tried to show over here. And I was talking about differences between V5 and V6. This is also another difference, right? So in V5, let me show you something. Let me show you something over here. Something very, very interesting. So let's say I do let caller be equal to self.end.caller. This is how you find out who is calling the contract. You can see that this actually returns the address of the caller, but it doesn't return an account ID, even though I said the account ID is the representation of the user wallet on chain. But when you call this self.m.caller, it returns an H160. What exactly is this H160? So the H160 is a 32-byte array. The account ID is a 20-byte array. This is a 32-byte array. I'm saying this more than once, more than twice, because we're going to run into a problem when we start writing our smart contract. And this particular thing that I've said 2-3 times, I want you guys to just, put it at the back of your memory. When we run into that problem, we're definitely going to run into it. It's not something that we can avoid. So this H160 is a 32-byte array, and it is EVM compatible. Someone said this works just like the use effects in React. Yeah, JavaScript guys. Oh, JavaScript guys. So the use effects in React, well, not exactly actually, not exactly. Use effects in React, it works slightly differently, right? Because the use effect does not really initialize the React component, but it works pretty much the same thing as a constructor in a TypeScript file. So if you're dealing with TypeScript class and you know how constructors work, this is pretty much the exact same thing, pretty much the same thing, just that is in Rust and this one is in JavaScript. I don't know if that makes sense. So this is H160, which is the equivalent of a contract address or a wallet address in the Inc V6. If this were to be like an Inc V5, this will not show H160. It will show something like this, account ID. You see, so this is a very key difference between V5 and V6. Also, one thing, if you are on Substrate UI, right, all your wallets use .inc. No, that is UI, yeah, UI.use.inc. When you come to this place, the wallets that you're going to be dealing with is the account ID, not the H160. So if I come here, you can see this is 5C83 is a 20 bytes array. It doesn't even start with an OX. So with a 0x, sorry. So this is an account ID, but this particular guy is an H160 address type, which is what the Inc V6 contract, that is what it speaks. So that's what it speaks on chain, not the account ID. So that's a key difference between them. We also have this hash. A hash is, well, think about a hash as pretty much the same thing as this guy over here, right? It's also 32 bytes, but it doesn't represent an account. So a hash is, let's assume you want to pass like an IPFS hash on chain and it's 32 bytes. You might want to represent it as a hash. So you pass in a hash into your contract, and this is readily available, right? Or you can also use the senior brother, which is H256. So this is like the equivalent in Inc V5. Did he export it? Did he import it? Yeah, he did. Then I want to see if I can open this guy. For some weird reason, it just keeps loading and loading. It's not opening. But all these things, yeah, it's opened. So you can see construct fixed hash. So fixed size uninterpreted hash type with 32 bytes. So it's 32 bytes. It has to be 32 bytes long. If you're going to be dealing with this H256, just like how I'm saying it here, you can see it's already letting you know that if you pass anything that's less than 32 bytes, you're wasting your time. So you have to make sure that you're passing 32 bytes. If it's not 32 bytes, you can pad it, you can pad it with zeros in front or at the back, just to make sure that it's up to 32 bytes. So that is one way that you can, you can deal with hash. So if you hash something off chain, or you're trying to hash like a Kekak hash or a single hash algorithm implementation on chain, the results will best be stored in a hash 256. Although one hack that I usually use is, sometimes I want to pass something like email address on chain. I use like a very stupid version of it. I'll just call it a VecU8. Because at the end of the day, this VecU8, if you pass a string like A, B, C, D, E, F, G, H off chain, it's going to accept it and it's going to interpret it properly, because the vec and the string, they're pretty much cousins, right? It's just that they have different first name, but they're the same thing. At the end, under the hood, they work very similarly. So you can use either one of them. And then we also have the balance. So we're not going to talk in much details about balance now, but we're still going to talk about it in this session. But just know that the balance, it allows you to, represent money on chain. So let's say the price of the native chain. So let's assume we're on Passet Up, where the token is passed. If you are passing like 25 pass on chain, you normally want to represent it as a balance. So it's readily available on the contract, but for what's it called? For Inc V6, let's see another difference. So let's say someone sends some pass into this contract, which is, to do that, you have to mark this as payable, right? This is another macro. It's the same thing as the Inc message macro, but the payable, it allows receiving value as part of the call of the Inc message. So let's say somebody wants to send some money as part of this Inc message. You have to, if you're expecting them to send some money, some tokens on chain, then you have to mark it as payable. I don't think that makes sense. So now you've marked this as payable. you want to make sure that they actually did send some money. So you're gonna say self.env. This env guy is a superman, like it is everything, it does everything, anything you need on chain. You can use it to get block number, the caller, the transferred value, you can use it to send tokens. So you can see it's actually representing it as a U256. If you look at this, sorry, so this is a U256, and this is how balances are represented on chain. On V5, it used to be balance, which is why, I was talking about balance over here, but now is now U256. On V5, actually, the balance used to be a 128 bytes array, right? Because the maximum, I think it's because the maximum decimal for like dots and so is 10. But on Ethereum, or on like even most EVM chains, the decimal is like 18. So you have like 1 times 10 raised to the power 18, which is like a very, very, very large number, right? I think it's larger than a U128 because let's see actually. U128 max value is 2 raised to the power 128. Actually, it's not that much. 2 raised to the power 128, let's say 2 exponential. This is on the side though, it doesn't have anything to do. I'm just trying to confirm like how large this is. 2 raised to the power 258 is a very large value. That's like 7 times 10 raised to the power. Oh, very large, right? Very, very large. Very, very large. Let's see 128. 128 is that raised to the power 7. Whatever though. It doesn't have anything to do with what we're talking about. We just deviated a little bit. I hope you guys don't mind the comic relief. So at the end of the day, what we have now is on V6, just know that V6, the balance is represented as U256. And I think one of the major reasons is so that it can be compatible with like EVM chains, So I think we've spoken about the exported types. I don't know if anybody has any questions about what we've spoken about. No question. Awesome. So now we're going to talk about how we can manipulate on-chain storage, which I think we've done like a little bit of it already, but we're going to do more about it within the time that we have. So the ink storage macro, this is our guy. This is our go-to guy for storing anything on-chain. We put it inside, we've spoken about it already. It's pretty much just a struct that has been defined using the ink storage macro. So how does this guy work? This ink storage, you can see that it has like key value pairs in the struct. Each of these key values, they are going to be encoded so that the palette revive or the palette contrast can make sense of whatever value you're storing. So you're going to have to, under the hood, ink is going to automatically encode them for you. So it's going to like encode them and give it some keys, like some key value. You don't need to know anything about these keys actually, but this is just useful for like under the hood to know how these work. So it's going to be like value, key value, key value, key value. You're storing the key and then you're storing a bunch of values under it. So what this struct actually tries to do is, I don't know if anybody is familiar with Solidity over here. Can you just give a thumbs up if you've written Solidity or something before? Awesome. So pretty much the same way as how Solidity packs storage. So if you're trying to store value on Solidity storage, it's going to try and pack it into like some cells, right? Each cell is like 32 bytes, 32 bytes, 32 bytes. So if you put value, you store it in 1 byte, add another value, 2 bytes. If it's more than 32 bytes, jumps to the next one and so on. This guy does something similar, right? So every value that you store, it tries to pack them into a single cell. It's called a cell in this guy in ink storage. So it's going to try and store each of these guys into a single cell if it can. If it cannot, then it's going to add a new cell and join it over there. Someone said, what is the difference between storage and memory in ink? Storage and memory in ink. I think this is coming from the concept of Solidity. Like Solidity has storage and it has memory. I don't think there's anything like storage and memory. There's only this ink storage. So now this is one thing. So normally, right, if you're dealing with a smart contract, when you read this value within here, where's that guy where we were doing that thing when we were trying to update? So let's say you say something like flippers. This is the vec flippers. Let's let it know that it's the vec flippers. And then you say self dot vec flippers like this. So this vec flipper is Redis, and it's not going to give you a reference. It's going to give you the vec flipper back. So pretty much at this point, if you update the value of vec flipper, if you say vec flippers dot push, and then you want to push, so you want to push something inside, you push something, bam, nice push, and then you just move on. You say, yeah, I've pushed it, and then move on to the next function. You've just shot yourself in the foot, because this vec flipper it's actually been read from the storage, and now is somewhere in memory right now. Please don't take this in the literal memory storage sense, but it works pretty much the similar way, right? So now these vec flippers, it's being remembered by this function. If you pass it into another function that this update flipper calls, you can also pass it as a reference and so on. But when you're done with whatever you're doing, you have to come back and say self.flippers, self.flippers is equal to these flippers that you just updated. Otherwise, your value is not going to be stored on chain. I don't know if that makes sense. So whenever you update a value in memory, just like how we've done right now, you always have to come back and update it back. So this guy is saying cannot find vec flippers in storage here because it's singular, not plural. So you have to come back and update it. This is failing because of how I structured it, but you can always convert it. But you get the memo, right? You get the point of what I'm trying to say. You get the point. So that's the difference between the storage. The storage is always in here, is always here. But when you read it within a function, it gets stored in memory. And when you're done with whatever you're doing, you have to update that storage back. Otherwise, it's not going to reflect in your storage. So very, very important point that we need to know. So that is one thing. And there's another way it works. So all this storage, they have to be initialized, just like how we mentioned earlier. You have to always initialize it. As you can see, there's even another constructor over here. So this one, all it does is implements the default values for all these guys. So which means if you're going to be doing something like this, every single value in here must have like a default value. In our case, everything has a default value. The Boolean, the default value is what? I think it's false. Flipper, the default value is 0. This guy, the default value is an empty storage, default value, empty vec, and so on and so forth. So which means if you're dealing with something like, let's say you want to store large number, let's say you want to store info, let's call it information. And this information is going to be a struct that is going to take information about somebody. So let's say struct information. If you just say user ID, account ID, pretty much the same thing that we were storing over here. But now we're going to say, because this guy has so much money, he's also married. Yeah. We want to know if they're married or not. So we're going to say he's married, which is Boolean. In this situation, all these guys have like default value. The account ID has a default value as well. So, but this struct, we really cannot say what's the default value, right? Because it doesn't have a default implementation. So what it means is your struct, whenever you do this, now we're having like, yeah, big errors. We're having big errors. We're going to talk about how to fix these particular errors with structs. But I know we walked through, I think, the DNS palette templates earlier last week. So you might have encountered how to actually fix this. So we're going to talk about that again in this particular case. So what this guy is expecting you to do is, I mentioned that for every value that is stored in this particular storage, it has to be scale encoded and decodable. And it also needs to be able to, encode it into like the storage key, which is one of the errors that this guy is talking about. Encode, required for information to implement pack, information to implement manual key. Like, what are all these guys? implement debug, implement all these guys, because it doesn't implement it. So we're going to see how we can address that. So pretty much, if you're going to store any value inside here, you have to make sure that one, and you want to use this default, it has to be able to, have like a default value. It has to, you have to let the storage know how to manipulate the keys. So how to handle the keys. You also have to let the storage know how to encode it and decode it as well. So we've spoken about initializing storage. We haven't spoken about overriding and reading values from storage. So we're going to talk about that now before we talk about any other thing. So if you want to override the storage, pretty much what I mean by override is, updating the values that has already been stored, because you've initialized it over here. And now what we want to do is we want to, you know what, we're going to have two functions. Let's have one of them to do like ink message to create add flipper. Add flipper. I want this to be as basic as possible. So this add flipper function is going to take something like a mute self, and then it's also going to take the user ID. You know what? Let's forget about the person's age and just focus on two things. They're going to focus on this one and the balance. So the balance, let's say U256. Let's just use the actual thing that you would normally use, which is the balance, something that represents a native chain balance. So the user ID is going to be something like, let me call it a H160, which is the expected thing. And over here, I'm going to call it H160 as well. Let's stick to the flippers, the storage vec version. Let's stick to the storage vec version, because we're sticking to that because normal vec, it's pretty much normal vec, so there's nothing special about that. So let's do this one that is at least a little bit not so intuitive. So it's going to take the user ID, and we also want to take the net worth of the user, which is a U256. One thing we want to do now is we don't care if it exists or not, because with the storage vec, you wouldn't even be able to know if it exists or not unless we have the ID. So the only way you can do this is to check if a user exists is if you know the flipper counts. So since we are already storing the flipper count, then you now say something like for counts in flipper counts. Let's say 0.2 self.flipper count, which is, this is not, it's not the best thing, but this is the only way you can check if a user exists in a storage vec. And then you now start from 0, and then you start going up, and then you start saying something like let's flipper. So you get the flipper, and then you say self.flippers .get, and then you pass in the counts, which is a U32. And this can be, because this is lazily evaluated, right? It's not going to know if it exists or not until it actually evaluates it. So which means you have to undo the use case where it is either some or none. Then you now say something like match. You can now match this, you can now match it, and then say some, whatever it is. You do the equivalent, and then you can now also do for none. If there's nothing, if there's nothing, then you can add it. If there's something, then we don't care. We just want to know if there's something or not. So leave that guy aside. We're just gonna return an error. We haven't spoken about how to return errors yet. So you know what? Let's just do that now. Let's talk about returning errors within our function, right? Let's talk about returning errors. So we're going to do something like for enum. So the error is pretty much an enum, very basic. And then it's an enum. It needs to be public, right? So that it can be accessed from anywhere. And then you can pass in the different errors that you want. the first error that we want is flipper already exists or flipper not found. Yeah, both of them. Or in case you try to update it. So now we can do this, and then we can now come here. Can now come here, and since we're trying to return an error, we now say result, which is the result over here, or error. We might get an error. It says, yeah, because there's nothing over here. So I'm going to pass in, it expects it to return a unit type. So now I've done that. And it's also saying type traits. Yeah, we have to read what this error is talking about. Encode is not satisfied. The trait encode is implemented for this, but it's required dispatch output, blah, blah, blah. It's talking about some errors, so some traits that need to be implemented that haven't been implemented, and that is pretty much most likely because of this error, right? Because now we're defining an error that is an enum, but we need to let the Rust also, we need to let Ink know how to encode and decode this error type, right? So, and that's what we're going to do right here. So we're going to do something like, this is a scale derive. This is a way to derive this. This guy, I'm just gonna say this, right? Just memorize this thing. Sorry, you just have to memorize this thing. But actually, you can always read it because it's part of the documentation over here, right? It's not something that you have to memorize. You have to memorize it, though. It's directly in here, so you can see right here. Let me just search for it. In scale derive, yeah, right here. So this is, and what are the encode, decode, and type info? Normally, right, you can just do this using like the normal derive macro, because what this guy is expecting from you is he wants you to allow this your enum to derive from these particular guys, which is encode, decode, and these encode guys, they're brought in from the scale. If you look at this, you can see scale encode, which is something that is also another crate that Ink exposes. If you look at scale crate, let me call it parity, so that it will be, so confuse it with another one. Parity scale codec. Let's come over here. You will be able to see that there's an encode and decode trait over here. Encode, decode, blah, blah, blah. You can do what I just wrote right now. You can do it the same way as this. So you can import the encode and decode, and then use like your normal derive macro, and then just derive encode and decode. But this is like a shorthand for it. So you don't need to import anything. Just tell Ink that Ink scale derive, encode, decode, type info, blah, 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 blah. And then, you also want to derive like the normal derivation, which is the normal create, maybe like debug, just to print the error to string. You want to be able to, compare it for equality. I think these are the most basic ones. It's even suggesting scale, encode, and decode, not knowing that I've already done it this way. So let's see if the error finally disappears. I think this error is a little bit stubborn. Oh, it's gone. Okay, the error is gone now. So now we can see that the error is gone. It's just asking us to implement that. So now we can just return error, error flipper already exists. No return. Yep. And this is one way to handle errors within your contract. So now if you go into your Ink UI and then you try to call this contract with, you try to add a flipper that already exists, you're going to get this error, flipper already exists. But one thing why this is not very optimal is because this storage vec that we just used, it can grow as large as possible. Like it's optimized to grow to like ridiculous lengths. You can store like hundreds of values in here. So imagine having to look through it individually like this, just to just to find if something exists. So you can think of this storage vec as advanced, what's it called? What's this thing? Last in, first out, that you can, yeah, like a stack. Think of it as a stack. So in a stack, right, if you wanted to, let's say you stack, like you want to serve people plates, you want to serve people dinner, and then you put their name on the plate, and then you start stacking each of them. But then somebody just comes from nowhere, he jumps the queue. Like, when you come to Lagos over here, we used to jump queue a lot. Somebody just jumps the queue and then is in front and is asking for his food, and then you have to search for his plate. You're going to run into it. You're going to run into troubles, because now you have to start picking the plates one after the other, looking for the names. That's pretty much what this storage vec is doing. It's not the same thing as you put the plate on the table, like just spread it out on the table. If someone comes and he has jumped the queue and he wants to eat ASAP, you can just look through and then just pick his plate and hand it over to him. But for the storage vec, you won't be able to do that unless you know the ID. So if the person comes and he says, look at me, I'm number 25. I should be at the back of the list, but now I'm in front. But just know I'm number 25. Give me my plates. You can just do what we did here, right? Serve.flippers.get number 25, and then you're going to get the person's information. Now, the problem will be when you get the person's information and then it doesn't match what this guy is telling you. So you fed the info, the name is Lamin Yamal, but he's telling you his name is John Jones. You already know that there's an error over there. So this is very easy for reading very large values, but it's not very optimal for looping through because of the optimization that have been put in place over it. So if you know that you're not going to be looping through the value too much, if you know that it doesn't matter, you can create the flipper as many times as possible. Even if it's already in the list, it can still be there again. Go ahead, you can use the storage vec. But if you want to, you want to make sure that every member of the list does not repeat, then your best bet would be to use like a vec, because a vec, at the end of the day, you still have to loop through it, right? But you can use like the normal functions, like you can iterate through it here, which is the right thing. You can do something like self.vec_flippers.iterate. And now, you can enumerate, you can do anything, but you can't do the same thing for the flippers. You can't iterate through flippers. You can't iterate through it, so which is where the error comes from. And it's not optimized for that kind of use case. So let's just go ahead and wrap up this our function to add flipper. Now that we've checked that the flipper does not already exist, right? We want to make sure that we can add the user. So let's see the caller. You know what? Actually, let's leave it this way. One thing that we can also do, you can do like access control. If you have an admin, let's say you stored the admin's wallet over here, or you could even do it like a const. You can admin wallets. But if the implication of using a const is that you can never change the admin anymore. Once you deploy this contract like this, you're stuck with this admin. So it's telling me blah blah blah. It's speaking Chinese or what's this? You can't call this as a const because you are actually doing some weird things over here. But if I do, let me see if I do something like this. Does it work? Let's see if this works. Yeah, this doesn't work either. It says expected H160 found integer, blah, 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 blah. You know what? Let's just leave this. One thing that is important is you can pass in an address, maybe you store an admin. You wouldn't want to hard code your admin anyway. But if you wanted to, you can read through this guy, the H160. You can read through the H160 implementation on the ink crate, and then you see how to define a new H160. I think that would even be fun for you to do that instead of me just writing it out here, just to put yourself through some stress a little bit. So now you can pass in the admin, and one thing that you can do is, let's pass in the admin, which is an H160, and then you're gonna say admin is equal to admin, right? What's going on again? What are you talking about? Expected comma. There's a comma over there already. Yeah, there's a comma already. Okay, it's working. Sorry, it's just taking a little bit. This Ross analyzer takes a little bit, some few seconds to analyze. I don't know if there's any questions so far, actually, because I think I'm not moving as slow as before. So if there's any question, please don't hesitate to ask. You can also, you can unmute and ask questions. It's always nice to hear you guys' voices. Let's close the test. We're not dealing with tests for now. We're not dealing with end-to-end tests. So what we want to do now is we want to make sure that whoever is calling this function is the admin. So that is why I added that. So I just want to add this extra check, just not to make the contract too boring. So now we want to check. You can say ensure, sorry, assert that, can assert that the admin is equal to the caller. So not just admin, you say self.admin is equal to the caller. But one issue with doing, you can do this like an assertion and then you pass in a string as an error message saying only admin can call flippers. But this is much more convenient, right? If you want the substrate UIs like this guy to be able to give you the error message appropriately, I think it's best to just return this error over here instead of this one, because this is going to throw. So it's going to panic instead of returning a response. So once it panics, you just see an error over here like contract interaction failed, and you won't know the exact reason why it failed. So it's always good to, like, if you're going to return an error, be sure to return the error the way I did it over here. So how you can do that, you can use like an if clause and then you do an else statement. But for now, let's just do this because this is finer to look at. I'm sorry. Let's just do it this way. Then you can now do self.flippers dot I think it's insert with these flippers with self.flippers dot, let's say, set. Yep. So you set it and then you put the index, right? So now how do we know the index? The index is easily, so since we already know the count, right, which is why I'm keeping track of the flipper count. So I'll say index is equal to self.flipper count. Now I'm going to say index plus 1, right? That is where I want to insert it. I want to insert that index plus 1 and I want to put the value. Let's see. Yep, no complaints. Wait, you have to pass a, there's no value in here. Sorry, my bad. We want to pass a tuple, so we want to put the user ID as well as the net worth. This is what we want to do. Does this work? And then it needs it to be a reference. Yep. What's going on? It says H160 expected ink U256, but you found U64. Yeah, that's correct because the net worth should be like, wait, where's that coming from? Oh, over here, because this is U256 for the balance. We made this U64 before. So now we have this and everything is fine. We've just added flipper to this place. Like pretty simple, right? Pretty simple. Any questions? Anybody have any question so far? Do we have any questions so far? Well, are we following along? Is it making sense? Awesome, awesome. Thank you guys. Thank you guys. So we've just done the overriding storage and we've also read values from storage. The only one that we haven't read from is the storage type of mapping. You know, we're still going to come back to that. So now let's deal with balances and payable messages. We've already spoken about balances. We've spoken about payable, right? But we haven't spoken about balances. So let's deal with let's do it this way. How do I show this? How do we show this? How do we show this? Let's say user balances. So for each flipper, right? Whenever they flip something, we're going to, let's say we're going to create a mapping of their address to their balance. So each time you flip something, we're going to increase your balance. Yes, on this contract, we're going to increase your balance on this contract. Every time you flip something, we're going to increase your balance. When you do this, what's going on? Oh yeah, I have to also initialize that. You see, every time you, and you know, one cool thing why Rust is very, very useful for this thing is it's very unlikely that you're going to deploy a contract that will fail, right? Because everything is going to be like, what's going on? It says this function takes 2 arguments. Oh yeah, because I didn't pass the second argument, because it also takes like an admin, right? H160 Oh, there's a default on it. Let's see. Let's see if it works. Yep, it works. So pretty much you can always just try this out like every time, because the reason why most of them have defaults, right, is ink exported. So just like I mentioned, if you're going to be implementing like this default constructor, you know, you have to make sure that every type in here can be defaulted. So like you have to make sure that they all have like a default value. So far it's not complaining because all these guys have like, they have like default, they implement the default trait. So we're not getting any issues. But if we're using types that do not implement the default traits, we would have gotten some errors along the way. So where were we? User balances. You're trying to deal with how, so let's assume that you flip, and then let's say you want to unflip. This is just like, this is just dummy thing, but let's call it a function that unflips. So when you do this unflip, right, what it's going to do is it's going to check how much you have, and then the contract is going to send that to you. So it's going to check how much you have, and then the contract is going to send that to you. And what we want to do is get all these guys away. So you as the caller, you have to be the one to call it. Then the first thing we want to do is we want to check the user balances mapping, just to see if you have anything to even withdraw, like you have money that can be sent to you. So we get the caller, and then what we do is let balance be equal to self.user balances. Just like the storage vec, the mapping is also lazily evaluated, just like I mentioned earlier. So which is why all you need to do is pass the user ID, and then you can, let's not unwrap, let's just do it like this. It's going to return an option. It's always, I prefer, I prefer doing this hard work of matching. You can always do like unwrap, or like, just do like an unwrap over here if you are sure that the value is going to exist. If you're not, you can also do like okay, or just return an error, and then you can return the error the same way I returned it in the add flipper. So you can just do error dot flipper not found, something like that. Let's just leave it here. So if you want, and then you can, this question mark allows you to, if there's an error, just return it up there. If you don't put it, you still have to, undo the result and all of that. So, but for now, just for clarity's sake, I'm going to take this out, and I'm going to do it with like normal match. I just want to match it. I'm going to match it, just match balance. And then if there's some value, if there's a value, it's going to return the balance. So it's going to return an H160 something for you, which is the value that we need. But if there isn't, it's going to return none. And now you can just return flipper not found, just like it is, or whatever error that you want to return. So if you actually have some balance, now we want to transfer the balance. And when you flip, sorry, when you add the flipper, right, you added this with like some money, sorry, payable, not. Let's assume you added it with some transferred value, which is what we can pick using like self.transferred value. So now to transfer this value back to the user, they have on flip, they don't want to leave their money with us anymore. So what we're going to do is we're just going to use our spammer self.end. This guy does everything, bro. Everything that can be done in a contract. It does everything. Then the destination is who? The user ID. And the value is what? The balance. The balance that we just did. And we're good, right? Let's see. This returns a value. It's going to return, let's see. Yeah, it returns something. So let's say let result is equal to this. The result can be units or an error. So units, we don't need it anyway. So just handle this. The only thing that we care about is the error that is being returned. So that error, this is not going to work though, because the error is not the same thing, right? So what you can do is you can match it. So if there's an error, you return the error like failed to transfer or something like that. So I think that should work. So now I'm going to say something like, the reason why this is still failing is because I didn't put this guy over here. But now that I've done that, you can see we're having the perfect thing. Everything is working. So who I want to send it to, the caller calls it. Now the smart contract sends the balance to the user back. One thing that you cannot do is on this chain. This is, it just sends the balance of the native chain, right? So let's assume you deployed your contract on Parset Hub, which is where you'll be deploying your V6 contracts. So assume you deploy it on Parset Hub. What you're going to be doing is you're sending some pass token to the user ID. One thing that you cannot do, a restriction that you cannot do, is you won't be able to send some tokens from user ID A to user ID B. That won't work, right? But you can say, if you want to do that, just do it off chain, just do a manual transfer. So you won't use the contract to do that. But the contract can send tokens out, and it can also send tokens back to somebody. So this is something that can be done. I don't know if that makes sense about balances of native tokens. Does that make sense? Awesome. Thank you, guys. So the next part that we're going to be dealing with is sending custom tokens, right? If you want to send, sorry, the AC over here, far boy from inside. So we're dealing with PSP tokens now. These PSP tokens, they're the same, they're like the Polkadot equivalent of ERC tokens. So you can have like PSP22, which is like fungible tokens. You can have like PSP, I think, I don't remember the exact number, but there's also the ones for NFC. I think it's 84 or something. But you can always check about PSP implementations. Open Zeppelin has like some implementations. Aleph Zero also has some implementations of PSP. Let's see Aleph Zero's on PSP dev portal. Where is this? Yeah, PSP tokens. So governance tokens, access controls, and all of that, tokens, multi-sig accounts. You can read all about all of that over here. So sending custom tokens like PSPs, they can be done on the contract themselves. We're not dealing with PSP tokens right here, but if you clone the what's it called? The PSP template from Pop CLI. Actually, can we do that? Let's see. No, let's not do that. I'll leave that for you guys to try out, because of time. So you can go ahead and try and clone the PSP template from using Pop Zero or from anywhere like Cargo itself. I think there's a PSP template on Cargo. So usually I use Pop CLI because I also do some contribution over there. So it helps me to see if there are bugs or anything. So, and it's much more seamless to use Pop CLI actually. Actually, I'll just recommend, I'm just being biased right now. Use Pop CLI. Don't use anything else. Use Pop CLI for everything that you're doing. If you're dealing with ink, anything, use Pop CLI. So depending on which one, you can transfer or receive. If you're transferring tokens from the PSP contract, the function to transfer already exists on that contract. So all you need to do is, just do your own implementation of the balance and transfers and all of that. So the only difference between native tokens is if you can't transfer native tokens on the smart contract from one person to another. So you won't be able to do something like, as you can see, when I said self.f.transfer, it doesn't even bother to ask me like, where are you transferring from? It just asks you for destination and the value because you can only send from the contract. But if this were a PSP token contract, then you'll be able to do something like PSP22 dot transfer from, something like this, and then you put in the owner, receiver, and value. And just like for my Solidity guys, my guys, just like the same way that you have to do approval before you send tokens, you also have to do the approval. Although there's a way to do like approval and sending in one single call using like Polkadot, and frankly, if you go through the PSP implementation, you will be able to find that out. Probably if you have like more time tomorrow, actually, because tomorrow is going to be for practical, we're going to get like, I plan to give us like a very, very simple assignment that we can work on. The aim is for us to build like a wish list application, so a wish list smart contract. Wish list, it means anything that you think it means. Like you can build it anyhow you want. You can do your wish list and you just try and use the concept that we have discussed over here. Try and have a function that collects value. Try and do a function that will receive the address. I actually want you guys to do a function that will try and receive this H160. It's not easy. Honestly, it's not something that's easily done. So I want you guys to do it and we'll talk about it tomorrow. So that would be like a very interesting conversation for tomorrow. I think some people will be able to do it actually. It's not an easy thing because the reason why it's not easy, let me just give you spoiler alert is so I have something like that over here actually. I have a function that I've created. So you can see register organizer. So this register organizer, it's supposed to take an address, and the address that is expecting is an H160 address. So if you do something like what I'm just doing is I'm copying my poker.js wallet and then I'm going to paste it, and then his contract reverted, like he's never going to succeed. So we need to I want you guys to try and find a function that takes this H160 and try and find ways to pass this H160 directly to your contract. That would be a very interesting thing that we can do. And it will also give us insight into how the H160 works. So for now, I think let's see what else is next. I think this is the last page, right? Oh, unit testing. Wow, I almost forgot about unit testing. Yeah, let's say something about unit testing actually. Let's unit test one of our functions, and then we can go ahead. But unit testing in contract. Now I'm talking about unit testing. I'm not talking about end-to-end testing. I'm talking about unit testing. There are different things, right? Unit testing in a contract, it works pretty much the same way as unit testing in a normal Rust function, like in a normal Rust library. What you need to do is, oh, sorry, someone said I'm breaking. Oh, okay, others are hearing me. I think it's your network. Sorry, Rich, maybe you try and join again. So let's look into the unit testing. Let me use this one to do an explanation. Quite a bit of them are failing because of how we define this guy. So quite a bit of them are failing. But the unit testing that we're going to be doing on this place, the major difference between this and like the normal unit testing in Rust is you have to inline this. So you can't say you want to put the test in like a new file, test.rs, and then you now copy everything from here and put it inside. You're going to start getting errors. And the reason why you get errors, it has to do with this macro guy over here, this in contract macro. So it's just for in contract macro, for him, it's just like, please don't let me do too much work. Just put everything that you need in one place. I'm begging you. So that's pretty much what it's asking you for. So it expects everything to be in one place so that you will be able to, interact with the contract easily. You won't have issues interacting with all these types that are automatically imported because you are dealing with this macro. So we are able to use like account ID, hash, all of these guys, ink storage, all these guys. We are able to use them because of this macro over here. This macro, when it sees ink storage, it knows what to do. But if you put it in another file, now you have issues. Although I have there's a hack that you can use. Since it's a macro, you can, define a macro to do unit testing. It's not very simple. So the simplest approach is just put it inline. So just inline the unit test and do something like this. So one thing that I usually like to do, right, when I do my unit testing is I like to have like a function that will initialize the contract. And I usually call it build contract. You find it in a lot of other functions. They call it build contract as well. So I think our function is called demo v6, right? Yeah, demo v6 inc. This guy over here. That is what the storage is also called, demo v6 inc. So we're going to pull this demo v6 inc. That is what we're expecting this function to return. And easily, what this guy is going to do is he's going to say something like, depending. So in our case now, we're not doing a lot of things. All we do is, we just do something like this, and then we're good. If you also want, you can, there's also a very, very useful crate for unit testing that we're going to talk. I'm going to show you how it works now. So you can get like default accounts. When we were dealing with testing on testnet, we could see some things like Alice, Bob, blah, 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 blah. So you can, if you look into InkEnv, there's the InkEnv crate that allows us to do like unit testing. Because I've done like quite a number of things, I usually do this quite often. So this is a function, sorry. So this is a function. What's going on? Yep, this is a function. And what is going to return is pretty much, in fact, let me do it this way. So it doesn't look like I'm just pulling this out of a wizard's hat. Let's copy this whole thing and paste it in here. I'm trying to let us go into the InkEnv crate and see all the superpowers that this guy has. Ink environment. So this guy is a Superman. So you can see operations on the off-chain testing environment. Okay, let's open this. Now you can see default accounts. So these default accounts, it exposes like 1, 2, 3, 4, 5, 6 default accounts for you. They are dummy accounts, so you can just use them anyhow you want. They are dummy accounts. So what you want to do is you just want to return those. You just want to return them. So pretty much what is happening here. You want to return them. So now since we need let's do this. So now we have an instance of our contract, but we want our admin to be a human being. So we don't want our admin to be, just anyhow person. So what we're going to do is we're going to see admin should be equal to default account dot Alice. Should we use Alice? I mean, Alice in Wonderland. One of my friends' name is Bob, so I'm going to use Bob just for the sake of it. This is a function, right? You need to call this. No, this is how it works. Let's see one more time. Pub if yeah, just a function. So you need to call this, and then you should be able to now pass this in here. Admin dot Bob. Yep. So now our admin is Bob. Thank you, Bob, for being our admin. So now what we want to do is we want to test one of these functions. Let's test this one that adds flipper. So let's try and add a flipper to our contract. So let's say pretty much the same thing, no difference between like ink, right? So you say default, no, let's say function add flipper works. The key thing about this InkEnv is once you like unit testing is once you get familiar with this crate, just know that it has everything that you need. So you can simulate like block advancements. You can get the current person that called the contract. You can get the account balance, which is the native account balance. You can set transferred value. So if you want to pass value like a payable contract, you can set the value transferred. You can, there's one other one that I also want to do. You can also read recorded events. So if you want to test events, we're not talking about events over here, but events are like very, very, very important in your smart contracts, like very important. Although they can be expensive to use, so you need to use them like with a little bit of thoughts, right? But events are like very, very crucial when you're dealing with smart contracts. So let's test this our add flipper function without further ado. So the first thing we want to do is we want to build the contract. So let's say contract is equal to build. So you see how this saves us the stress of having to write this function. I mean, in this our case, it's not a lot of things. We could just copy and paste it, right? But imagine that you have to do some minor computation before you build the contract just to get some values and all of that. Or if you're passing too many values, you don't want to be doing that over and over. So we do the build contract. And then, before we do something, we can just say set next caller. We can set our caller to be ink.env.test, as you can see. So it has all the functions that we need, set caller, and then let's set it to be You know what? Let's set it to be anything. Let's set it to be someone else. Instead of Bob, let's let Alice. Alice is trying to cheat Bob and trying to call the contract on her own. She didn't say she did wise. So let's play along with her for now. She's trying to call the contract instead of Bob. And the next thing that we want to do is we now want to call the ad flipper. This ad flipper is going to take these values over here. So let's say um contract dot add flipper user ID. Who does he want to add? He's trying to act as the admin and he wants to add, you know what, let me do it this way. Instead of having to write default account or default account, I'll just do something like default accounts. And then I think I should be able to have access to, oh, sorry, JavaScript is taking over. Alice, I think, Bob, wait, what's going on? Should be able to do, I'm trying to destructure this guy, but he's not destructuring. Let's leave that for you guys. You guys can figure out how to destructure it on your own. So act, so you just say act dot, let's say he wants to add Django, yeah, Django, and then u256 dot from, let's say the net worth is 500. A very rich flipper. So because we are mutating, as you can see, add flipper, it takes a mutable instance. So we need to make this a mutable instance as well. So let's see if this works. I think what's going on over here is defined multiple times. What do you mean? Oh, we don't need to define now. Let's just keep this one. Let's keep this one. You know, instead of doing this, right, we could have just reported it like this, but I like stress, so let's just go through the stress that we put ourselves in. So now I'm gonna try and we haven't even built this contract. Let's try and build it. Let's try and build this contract. Hopefully it builds. I expect it to build actually. And if it doesn't build, it should let us know why it's not building. So let's just wait a few seconds. Building a contract for the first time, you know, it takes like a little bit of time. So while we are building this, does anybody have any question, anything, like any concerns, any confusions? Just please talk about it now. Why this guy is still building? It looks like this one is going to take like 20 hours to build at this rate. You know, somebody was complaining about this build process. Like you have to have like a good computer to be able to build, to be able to write like ink smart contracts. And then we checked the release size and it was like 5 gig. Honestly, that's something. I mean, honestly, we should be able to optimize that process. But if you think about why we have all those, right? Because at the end of the day, when you build your smart contract, usually if I didn't use that release flag now, it's going to build an instance for like offline testing, and then it's also going to build another instance. So it's going to build it in 2 different places, but they are used for 2 different use cases, right? But using the release flag is only going to be half the size. Although it's still large, it could be like 2.5 gig, depending on what you're doing. It can be like 2 gig or so, which is quite a large file actually. So usually, if you're building like a smart contract, you want to ignore this target folder. Otherwise, you just be bulking up like storage and GitHub. You know, you have to push all this code to GitHub. This file alone could be probably like 2 gigabytes. So usually you want to ignore all these things inside the target file. You might also want to ignore the cargo.log because whenever you do like a build, this log is going to come back. Target is also going to come back as well. So we've done our pub build. It's still building, still building. Let's just wait for this guy to finish building. The good thing about this building process is for the first time you build it, it takes a while because it has to do like a lot of compilation of all the craze that you're using and all of that. But subsequent builds are not as slow and they're not as heavy as what we do in the first time. So let's go. Let's go. It's gonna take a little bit more time. In the meantime, you can still ask any questions. We still have like a few minutes left. Unfortunately, we won't be able to test this contract on the contracts UI. If you guys want us to continue, though, we can continue. I'm just looking at the time. Oh, just do the remaining 15 things that's left. So it's very important.
I think network threw him out. I don't know if anyone can hear me if I'm still on the call.
Yes, we can.
Okay. So maybe we should wait for a few minutes. What of Polkadot? Polkadot, are you on the call?
Hey, sorry, can you guys hear me? Yeah, I had
Yes, yes.
awesome. Sorry about that. The power went off. I had to turn on my inverter. I'm back now. So unfortunately, our contract it refused to build. Let me share my screen again. Oh no, this is not what I want to share. Is there something else? I want to share the entire screen one. Yes. So it failed, and that is because this PSDP22 that I used for like sample, I forgot to remove it. So that one failed. And then it's also failing because the vec that I'm using here, I didn't bring it into the crate. So this vec is actually within the ink prelude crate, just like I mentioned in the beginning. So if you're going to use vec, normally in Rust, you don't need to import vec, right? Vec is available. But for ink, you have to bring it in from ink prelude. So those are some errors. Let's build again. Building this time around shouldn't take so long. So it didn't take so long this time around. Let's see. It's taking a little bit of a minute. It's taking a little bit of time, but in the meantime, I think you can just make sure everything is going to be fine. Okay, this one, I think this is something that comes from scale info, independencies, blah, 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 blah. This is something from Rust Analyzer actually, so it's not really an error related to our code, but scale info, right? You know, this type info, it's actually usually gets imported from scale info. So sometimes it's going to ask you to put it in your cargo.toml. So let's see scale info over here. So this is the scale info crate. So that's where the type info usually comes from. So if you were going to use like a normal derive, you do like derive scale info. But because I'm using this pattern, this ink scale derive, I don't really need to import it anymore. And that's why it's not failing when it's not going to fail when I build it. But the building is just taking a little bit longer, a little bit of time. Let's just give it like a couple more seconds. We want this to be done, and then we are going to run the test. The test is going to fail when I run it because Alice is the one calling it, while Bob is the admin on the contract. But I just want to show us that I expect it to fail actually. No, 76787. Look at all these guys that are compiling. This is like a whole lot of things. Proc macro, SEDI version for encode and decode, Rust version, with generic array, norm traits. I'm not even using this norm traits. Who cares why it's just compiling? These are some of the things, and all these guys are going to get compiled, and at the end of the day, they're going to add to the size of the target folder. So at the end of the day, smart contracts, you know, they usually get heavy like that. Even if you're dealing with like EVM contracts, you're dealing with like hard art or foundry, you still get this like very large size. So our contract is successfully built. So usually what I do in this case is I don't even have to do anything else. I just go to Substrate UI, upload this contract, and then I can test it. The only thing that I usually work with is also pop test. So we want to test the contract just to make sure that it's working. The pop test normally shouldn't have to rebuild again, though. Is it because I'm using the release flag? Because normally you shouldn't have to rebuild again since I've built it. So because I think it's because I'm using the release flag. So usually if I do pop build, it's going to build for test as well. You know, I mentioned earlier as well, which is why it gets like double the size. But because I am using release, when I do pop test again, it also wants to do its own build for testing, just to set up all the environments. But let's just be patient for it. Let's see if there's any questions. Any question that I might have missed. A little bit over time. Just want to show us this testing, just to show us that it works or not. You know, normally we want to make this Bob instead of Alice. It's taking long to compile for a test that's going to fail. Yeah, the day it's still gonna fail anyway. This palette balances, palette asset conversion, think end-to-end macro. Need to look into like talk about why all these crates are actually being compiled, all these guys, even though it doesn't feel like you are using them. But these are crates, these are palettes, these are things that are being used, that are needed on the on the palette revive or the palette contracts where the contract is going to run. So all of them have to be compiled as part of the contract, as part of the bundle. So You see why there's quite a lot of things that need to be compiled. It looks like we're finally close to the end of our compilation. And this actually passes, right? Which means our check somewhere is not successful, right? Because we expect this to fail, right? But it actually passes, even though we set the default accounts to this, and then when we do add flipper, oh yeah, only admin can do this. Assert that the self.admin is equal to the caller, and then if it's not, then only admin can call flippers. So self.flipper count. This shouldn't actually work, but for some weird reasons, it's working. Interesting, right? Very, very interesting. Set caller. Let's set it to Bob and see if it works for Bob. Let's set it to Bob and see if it also works for Bob. It also works. Interesting. Let's see. Because I expect this to actually fail. So we get the f.caller, which is the caller over here. Then the self.flipper.get, blah, blah, blah. So flipper already exists. If not, okay. I think, so it's working because we're not really doing anything, right? Let's try this. So we're not doing any assertion. So assert that result is okay. So let's do this assertion over here. Because even though it's failing, we are gracefully handling the errors, right? So it's not panicking per se. So let's try this and see if it works as well. This guy still works again. Mad. It says set caller, unless this is not working. Let's see. This is quite funny actually, because normally this shouldn't be working. It's supposed to fail, right? So you know what? Let's do what I didn't want to do before. Let's do it this way. Let's mute contract should be this, and then we want Bob to be the one that's calling, and then we're not going to change this to like Alice so that Alice will be the caller. Okay, maybe no, maybe it's because of this. This is where the thing is coming from. Only admin can add flippers, and then let me try this. If, let's say, if self.admin is not equal to the caller, then return error. Let's say flipper already exists as an error again. Now let's try it one more time. Here it's failing. It says you can't find admin. So our admin is going to be Bob. Because I actually expect this thing to fail. But now it looks like our contract is too good for us. It just keeps on passing. It still passes again. Interesting. Says test result 0. No, there's a way to. Let's see variables. Is it a single slash? Oh. Unexpected arguments to pass V as a value. Let's see. Test options. That one should be failing actually, but the fact that it's passing, it's a little bit confusing, right? Oh, sorry. Unexpected. A similar argument exists, which is node. I'm trying to see. Okay, let me see. Test help. So I want to print it variables. Wait, did we push this update for variables? I think we did actually. It's not here. Usually when you do like the cargo test. 1 second. I want to see exactly. Oh, too much verbosity now. It's saying too much. Saying too much. Says test profile, blah, 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 blah. But they're all passing though still, which is the weird thing that we're trying to debug. What exactly? Why is it passing? Now this is not how the verbosity should come up though. This is just a bunch of jargons. Let's see. It has to be something from within this flipper contract, though. You say if self.admin is not equal to the caller. So does it think the caller? No, let me remove this one. And then the default caller should be not available. Add flipper works, even though it shouldn't work. Interesting, very, very interesting one. Which means it's not even doing this check over here for us. This add flipper check. If self.admin is not equal to caller, because we want the, you know what, let's try and see the admin. Yeah, that's the first thing. Let's test that one. Sorry, we are way beyond time already. Sorry. I don't know. Should we still keep going? We just need like 10 minutes, and then I'm gonna release us. I just want to check. I want to show this testing, right? Let's say initialize works. So we want to do, yep. Now contracts as admin, assert equal, blah blah blah. Contract that gets false, flipper count 0. Okay, good. Now let's test. They're all passing, right? So now let's test this to be Alice. This is where we're going to see if the admin is actually being set or not. It fails. So Alice and Bob, they're failing because the left, this is Bob's address, and this is Alice's address. So what exactly is the reason why this second function is being stubborn and failing? Unless this set caller does not work. So we get the default accounts. We pass Bob as the admin, and then we to call using Alice, and then contract.add flipper result dot. Let's see, test if it's error then. Okay, initialize works. It doesn't work. No, one thing. Still don't know what's going on over here though. My guess is, so this fails now. So it expects it. Oh, it expects it to be okay. It should be an error actually, right? This should be an error, right? Not okay. Because contract.add flipper should actually fail if somebody other than the admin is the one that's calling. And the caller over here is not Bob. The caller over here is not Bob. You know what? One thing I'm gonna do is I'm gonna push this so that I don't waste too much of our time. Just know that you can use like this ink env to run all the tests that you want to run within the contract. So everything that you need to do, set caller, get account balance, do anything, you can do all of that. Set a caller for the next call, set the callee for the next call. Yeah, shouldn't work actually. So maybe tomorrow we'll look into why this one is not working, just so that we don't take too much of our time and too much of our attention span. Ooh, that was a deep one. Very good one anyway. Does anybody have any questions? I mean, we're pretty much done for today's session. We can try our hands at, trying to build like a wish list contract against tomorrow, and then tomorrow we will discuss any issues that we encounter. Then we get like practical hands-on into building smart contract, doing like ink testing over the next 2 hours for tomorrow. All right. Thank you very much, guys. Polkadot.Africa, I think you can take over now.
All right, let me stop recording. Thank you so much, Bolaji, for that.